Dear ladies and gentlemen, thank you very much for giving us the opportunity to present our latest research on the energy-carbon-water nexus at the Applied Energy 2020 online conference at MIT and Harvard. I will give a short introduction to our research theme. I will describe the challenges of the private and public goods for the energy-carbon-water nexus. I will present the databases of our model, and I will discuss the first results and try to give an answer to a difficult question. According to the German Environment Agency, climate change and its consequences have already reached Germany in the hot and dry summers of 2018 and 2019. The drought continued in 2020, as this NASA satellite picture of the European groundwater status shows. A severe drought has covered Central and Eastern Europe. The German Weather Service expects that the average temperature in the years 25 to 29 will even be 1.5 to 2 degrees higher than the average temperature of the reference period 1981 to 2010. The drought of 2018 also affected the agricultural sector in Germany, so that the federal and state governments have provided drought aid amounting to 340 million euros. These events increased the already high public awareness of climate change in German society. In 2019, 68% of the German population rated environmental and climate protection as a very important challenge, giving it a similar importance as the other two top issues, education and social justice. Compared to the 2016 survey, environmental and climate protection has increased its importance about 15 percentage points, as the figure shows. Given now the long history of research on climate change, its causes and effects, and its increasing public awareness, necessarily which ask a simple question: why did we do this to ourselves? And he describes the dilemma of current climate energy politics between scientific knowledge, public environmental awareness, and implemented climate protection policy. One answer to resolve this dilemma may be provided by the public good concept developed by Nordhaus and Samuelson. According to Samuelson and Nordhaus, public goods are defined by two main characteristics: non-excludability and non-rivalry. They can further be divided in pure and impure public goods, and in global public goods and bads. A river dam is a pure public good. The dam protects everyone behind it. There is no excludability and no rivalry in benefiting from the protection of the dam. A fitness studio is an impure public good. It is characterized by non-rivalry in using the club when being a member of the club. However, access to impure goods is not free for everybody. Global public goods are the Earth's climate and Arctic sea ice. Global public bads are the CO2 emission. The global public goods differ from other market goods, but also from normal public goods, as Samuelson and Nordhaus pointed out. They stated, If problems arise concerning public goods, such as global warming, neither market participant nor national governments have appropriate incentive to find an efficient outcome. The marginal cost of investment to any individual or nation is much less than the global marginal benefit, and underinvestment is a certain outcome. Accordingly, the following public and private goods are summarized in the energy carbon water nexus. We have one global public good, the Arctic sea ice, a global public bed, the CO2 emission, an impure public good, safe drinking water, and a private good, energy. These different economic goods are summarized in the energy carbon water virtual nexus and building the core of a sustainable development. For our analysis, the German household expenditure survey data sets of 2013 published from the Federal Statistical Office were used. We are currently also analyzing the latest data sets of 2018, published some weeks ago. With respect to the social distribution, the table reveals that white-collar workers are the largest social group, followed by the retiree households and the blue-collar workers. The remaining groups are smaller, consisting of self-employed, unemployed, and the group of the public servants. The second table showed that the level of monthly CO2 emission strongly depends on the social position of the main income recipient and on the income class. Whereas households of self-employed, public servant, and blue and white collar workers emit on average more than or close to 400 kilograms of CO2 per month. The groups of the unemployed and retiree households emit on average only 182 and 216 kilograms CO2 per month, whereas the groups of the self-employed and blue-collar workers in the highest income group emit 616 and 619 kilograms of CO2 per month. Public servants and white-collar workers emit 593 and 548 kilograms of CO2, while CO2 emissions are lower among the unemployed and retiree households. The Rawls dispersion is defined as a measure for the distribution between the lowest and the highest income group of a social group. Whereas the Rawls distribution is the lowest for the household group of self-employed and white-collar workers, it is the highest among the group of the public servants and the retiree households. The Rawls dispersion visualizes the presence of the spread between the highest and the lowest income group for stability of society. The concept of an energy carbon water virtual nexus is used to summarize the various economic goods and to evaluate German household groups by analyzing the expenditures of the households for energy and water. The CO2 emissions costs are calculated using a CO2 shadow price of 80 euros per ton of CO2. The energy expenditures are directly drawn from the survey data. The considered water expenditures include also the virtual water costs of the German household, the estimation of the virtual water consumption related to imported private consumer goods. The results show that the average nexus expenditure are the highest among the civil servants, followed by the self-employed, the blue and white collar workers. The unemployed and retiree households have the lowest average nexus expenditures. The Rawls dispersion is the highest for the group of the civil servants, whereas blue-collar workers, retirees and unemployed households show values in the medium range. It is lower in the group of the self-employed and white-collar households. Hence, the distribution analysis reveals distinct inequalities in the distribution of the energy, carbon, water, virtual nexus expenditures among the various German household groups. The Arctic sea ice, a global public good, reaches its smallest seasonal expanse in September. According to NASA data, the average Arctic sea ice minimum in September has declined by 56% between 1980 and 2019. During the same period, the CO2 emission concentration in the atmosphere increased by 21.5%. This link between the decline in Arctic sea ice and rising CO2 emissions was also approved by Notz and Ströver in 2016 and 2020. The authors were able to relate the loss of sea ice directly to CO2 emission and found that every ton of CO2 reduces the summer Arctic sea ice by roughly 3 square meters. Given this link, it is now possible to calculate the specific contribution of the different households group in Germany to the degrees of Arctic minimum sea ice. The table shows our first model results about the annual CO2 emissions of the German household groups and their differing impacts on the summer Arctic sea ice shield. The largest average Arctic sea ice reduction is caused by the average public servant household, followed by the self-employed and blue-collar workers. With a certain distance, the white-collar workers, the average unemployed and retiree households are responsible for less Arctic sea ice reduction. The Rall's ice spread is also the highest for the public servants, followed by the retiree households and the blue-collar and unemployed households, whereas the spread for the self-employed and white-collar workers is lower. Across all household types, the highest income group of the blue-collar workers causes sea ice reduction that is 7 times higher than that of the lowest income group of the unemployed and retiree households. Overall, the highest income groups of the self-employed, the public servants, and the blue-collar workers are responsible for the highest individual contribution to the reduction of the summertime Arctic sea ice. We further analyzed also the total Arctic sea ice reduction caused by all analyzed German households according to their income and social group. The table shows that the highest analyzed income group causes 26 times more IC reduction than the lowest income group. Across all income groups, the highest summertime Arctic sea ice reduction is caused by the group of the white-collar workers, followed by the retiree households and the blue-collar and unemployed household. By far the least reduction are caused by the social group of the self-employed households and the public servants. In summary, all analyzed households together cause a reduction of summertime sea ice that equal Lake Constance in Germany. Given these results, the energy, carbon, water virtual nexus may be one concept to overcome the dilemma of Nathaniel Rich, because it enables to summarize the various economic goods with its different characteristic in one analytical term that can support policy and decision makers. The next research steps are the outline of institutions which can manage simultaneously the private and public goods, the global public goods and bads of the energy, carbon, water virtual nexus. These institutions can develop socioeconomic measures and incentives to overcome the rich dilemma. Thank you very much for your attention, and I'm happy to answer your questions.